Hello geometry students, here's your lesson for section 4.6, triangle congruence, angle, side angle, 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 side, and hypotenuse leg with Missy McCarthy, math instructor at Okemos High School. By the end of this lesson, you should be able to say that I can identify included sides and non-included sides in a triangle. I can apply the angle, side angle, 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 side, and hypotenuse leg congruence theorems and postulates to solve problems and find missing angles and side lengths. I can determine if either of those can be used to prove that triangles are congruent, and I can prove that two triangles are congruent by angle, side angle congruence postulate or the angle, angle, side or hypotenuse leg congruence theorems. So let's find out what all that stuff is. You already had two congruence postulates from the previous lesson, so we're adding a third one today, and that is the angle, side, angle congruence postulate, which says that if you have two angles and the included side of one triangle congruent to two angles and the included side of another triangle, then the two triangles are congruent. What is meant by included side is you have, say, angle A right here and angle C right here. The included side is essentially the side that is between the two angles. So in this case, side AC is between the two congruent angles. And if we look at angle D and angle F, side DF is between the two. So that's what we mean by angle, side, angle. The side is between the two angles, the included side. We also have our first theorem. This one says if two angles and a non-included side of one triangle are congruent to two angles and a non-included side of the other triangle, then the two triangles are congruent. So here's what we mean by non-included side. In this particular triangle, we've got angle G and angle J. They're congruent to angle K and angle M. Now the side that we have congruent in this case is HJ, and the other side is LM. Notice that those sides are not between the two angles. So that means we would say angle, angle, side, because the side is not included between the two angles. So this is the angle, angle, side congruence theorem, and it's a theorem, which means we could prove that it was true. And our last congruence theorem is called the hypotenuse leg congruence theorem, and it specifically refers to right triangles. So you cannot use this congruence theorem unless the triangles are right triangles. It says if the hypotenuse and the leg of a right triangle are congruent to the hypotenuse and leg in another right triangle, then the two triangles have to be congruent. Remember, the hypotenuse is the side across from the right angle. So we have leg BC congruent to leg FE in this right triangle. We have hypotenuse AC congruent to hypotenuse FD in the two right triangles. And because they are right triangles, the hypotenuse leg theorem says that those two triangles are congruent. Again, this is a theorem, so it can be proven. All right, so all we're going to do in this next couple of examples is determine whether or not we have enough information to prove that the pairs of triangles are congruent. Remember, our options are angle, side, angle, 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 side, or hypotenuse leg. In this first pair here, I'm going to write it over here, angle, side, angle, 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 side, and hypotenuse leg. In this first pair here, there are no right angles, so hypotenuse leg is out. Now I got to determine whether or not I have angle, side, angle, or angle, angle, side congruence. PQ is the side that I have congruent to ST. PQ and ST are both between the two included angles. So angle P and Q are congruent to S and T, and I have an included side. So that means, yes, I can determine that these two triangles are congruent by angle, side, angle. On this case right here, oh, it's not angle, angle, side. It was angle, side, angle. In this case right here, there are no right angles, so hypotenuse leg is out again. And then I try to determine, I have two congruent sides and one congruent angle. Do I have anything that has two congruent sides, two S's and one A? And that would be no, so our answer here is not enough information. Okay, let's try another one. Again, I'm going to write my choices, angle, side, angle, 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 side, and hypotenuse leg, angle, side, angle, 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 side, and hypotenuse leg. I do not, again, see right angle marks. Looks like they're right angles, but I see no marks. All I see is one congruent pair of angles here, so that gives me an A. Another congruent pair of angles here, so that gives me an A. I don't see any congruent sides, so it can't be either of these. Wasn't hypotenuse leg, so not enough information. For this next example, I see right angle, so hypotenuse leg is a possibility, but let's check and make sure we have the leg and the hypotenuse. So QR is a leg, EF is a leg, they are congruent. PR is hypotenuse, DF is hypotenuse, they are congruent. Hypotenuse leg of right triangles are congruent, so therefore those two triangles are congruent by hypotenuse leg theorem. All right, and here's our last two. Again, our choices are angle side, angle, angle, angle side, and hypotenuse leg, angle side, angle, angle, angle side, and hypotenuse leg. So here I have one pair of congruent angles, a second pair of congruent angles, and then this side AC is not between, EF is not between the two angles, so we have angle, angle, side. For this one, I have congruent angles there and there. I have a congruent side there and there, so I at least have an angle and a side. Can I get another pair of angles congruent? And the answer to that is yes. These vertical angles are congruent, and that makes this side between the two angles, so we have angle, side, angle congruence. But we would have to prove that using the vertical angles theorem. All right, do we have enough information to determine that these triangles are congruent? Well, yes, we have two pairs of congruent angles, that's for sure. Two pairs of congruent angles. Do I have a pair of congruent sides? And the answer to that question is yes. This side right here, if I were to call it MN, lies in both of these triangles, and side MN is congruent to itself by the reflexive property of congruence. So because we have two pairs of angles and then we have sides, is this side between the two angles or not? No, the included side would be right in here somewhere or right in there, and so it is not. So these triangles are congruent by angle, angle, side, triangle congruence. All right, in our last example, here is a proof. So they gave us some information about the two triangles, and we have to try to prove that they are congruent using one of our congruence theorems or postulates. I don't see any right angle marks, so I'm thinking hypotenuse leg is not coming into play here. So let's start with our givens. Angle X is congruent to angle V. That is given, and I am going to mark it in the picture. X is congruent to V. All right, so we got two more angles here. Angle YZW is congruent to angle YWZ. YZW, that's this one right here, is congruent to YWZ. That's that one right there. Okay, and that was given. So I know I'm using angle, angle, side, or angle, side, angle so far. Alrighty, so let's see what this gives us. XY is congruent to VY. XY is congruent to VY. And I'm trying to prove that triangle, oops, let me get my highlighter here. Trying to prove that triangle XYZ is congruent to VYW. We're trying to prove that those two are congruent. Oops. Trying to prove that those two are congruent. All right, so I think I see what I need to do here. So we need another pair of congruent angles, and what I'm going to say is that because these are congruent, that means this angle here is congruent to this angle here. So step 4 would be angle YZX is congruent to angle YWV, and the reason those are congruent is the congruent supplements theorem, because they're supplementary to two congruent angles, the ones that we have marked on the interior in purple. Okay, so these are congruent, these are supplementary to two congruent angles, so by the congruent supplements theorem, they are congruent. Congruent supplements theorem. So because we use the congruent supplements theorem, now in our yellow triangles we have two angles and the non-included side, two angles and the non-included side, which means that triangle XYZ is congruent to triangle VYW by angle, side congruence. As always, review your I can statements, and we will practice more in class. See you then.